Integral velocity. So the integral velocity can be used to calculate our displacement and sometimes our total distance covered. So let S of t be the position at time t of an object in linear motion. Then the object's velocity is v of t, and v of t is also equal to our the derivative of our s of t. And the integral of v of t is also equal to the net change in the position or the displacement over time interval from t1 to t2. So what does this look like on a graph? On a graph, let's say our v of t is our function. And on a graph, if we calculate the integral of v of t over the interval t1 and t2, then we should get the area below v of t, in between these two intervals. And this area pretty much is our displacement. Now, in this case, because the graph is entirely above the x-axis, and in this interval everything's above the x-axis, this is also our distance, our total distance. However, we must distinguish between the difference between distance and total distance traveled and displacement. So let's say if I travel 10 kilometers and then come back to the same spot, my displacement is 0. However, my distance traveled is 20 kilometers because I traveled 10 kilometers to get somewhere and then I traveled 10 kilometers to get back where I am. So displacement can pretty much be 0 or even negative if I moved backwards. However, even if displacement is, let's say, 0 or negative, our total distance traveled could be 100 kilometers or even 10,000 kilometers. So it's important for us to know the difference between the two. Now, what does the difference between the two look like on a graph? So here I have a graph, right here. And the displacement would be the area here. Let's say we're trying to get from our intervals from t1 to t2. Our displacement would be this area right here, I'm calling it right now, plus the area right here. However, because this area is below the x-axis, it would be negative, and this area will be positive, which means this area below the x-axis is actually taking away from the total distance, our total distance, which would give us the displacement. That's why when we're calculating total distance, we actually have to make this the absolute value of. So let's say this function is f of x, this graph here, we have to make it the absolute value of, which would make this also positive, and that will give us our total distance. And what does that look like on a linear path? It would look something like this. If we're traveling from t1, so our time 1 to time 2, and let's say we plug in time 3 just in between the t1 and t3, I mean a t2, and our time 3 is precisely when our velocity changed from being positive to negative, which means we actually went back distance. So our displacement will be this right here, and our total distance travel will be here plus this part. So we have to add a little bit of it to there. So this would actually be our total distance traveled, and our displacement is only how far we have left from our original spot at t1. So let's move on to an example. So our example here states that v of t, or velocity, is represented by this function. And this function states that t to the power of 3 minus 10 t to the power of 2 plus 24t is our velocity. And we have to find our displacement, sorry, there should be a d there, our displacement and our total distance traveled over an interval from 0 to 6. So let's find our displacement first, because that's the easy part. So to find the displacement, we simply plug in our function here into an integral, and the upper and lower limit of the integral is determined by our interval. So our interval is from 0 to 6, so our lower limit is 0 and our upper limit is 6. And when we calculate all that, we should get to the answer, when we plug in all the numbers subtracted, we should get the answer 36 meters. So the displacement is 36 meters. Now we have to figure out distance traveled. And to figure out the distance traveled, we first need to find when it crosses the x-axis. So when does the function cross the x-axis? So on the graph, our function might look something, I'm not sure exactly what it will look like, but it might look something like this. So we have to find exactly when it crosses this x-axis, so we know that the area below the x-axis, we have to count it as positive. Okay, so we find that by plugging 0 in as y, and we do our basic polynomial stuff, and then we find that our t can actually equal to 0, 4, or 6. That means our graph actually crosses the x-axis at 3 points, at 0, 4, and 6. And since our intervals from 0 to 6, we know that from 0 to 4, we have either a positive or a negative. Our graph is either positive or negative, and from 4 to 6, our graph is either positive or negative. And to figure that out, we will have to plug in a number between 0 to 4, let's say 2, and a number between 4 and 6, and let's say 5, and see which one is positive and which one is negative, which one is above the x-axis and which one is below. So we plug in 2, as I did here, and I find that the answer is 16, so we already know that this 0 to 4 is positive. However, for the sake of the video, I will just do this the second part and plug in, let's say 5. And I plug in 5, and of course I get a negative number, so I know that this area is actually below the x-axis. So now I have to separate the integral into two parts. The first part has an interval from 0 to 4, and our second part has an interval from 4 to 6. Then we plug in our function, plug in our numbers, and because our lower limit here is 0, I didn't even write it down because it would just equal to 0. And so we have this subtracting from here, which is the interval from 6 to 4. I mean from 4 to 6. Okay, and when you plug in a number and you figure everything out, you should come to 128 over 3 meters plus 20 over 3 meters. Now make sure it's not minus, because what we're trying to find is the distance, our total distance. And then we add them together, and then we get 148 over 3 meters. And that would be our total distance traveled. So just to recap what we have to do when we're trying to find our total distance. So first, we have to find where it crosses the x-axis. That's our very first step. Then we have to find which interval, during which interval is it positive or during which interval is negative, and then we can separate it into two parts from the knowledge that we have obtained. We can separate our function into two parts. So in this case, it will be from 0 to 4, and then from 4 to 6, and from 4 to 6 we know that the graph is below the x-axis. And then we calculate it, and then we add them up together, and then we get our total distance.